Now the next topic we have to study is chain rule. This method we use to find the derivative of a function or to differentiate a function. Okay. So before we start with chain rule, there are fundamental rule of differentiation. We will discuss these rules. So one very basic thing is um, how to represent derivative. So derivative of a function is represented by f dash x. We can also write it as dy by dx, as we say this f of x as y. So different. So it's this d by dx is an operator. Okay. So d by dx of, so how to write, how to read d by dx of y. Okay, dy by dx means differentiation of y with respect to x. Okay, how to read differentiation of y with respect to x. This is the way to read. So dy by dx is differentiation of y with respect to x. Suppose if I write dz by dx, it means differentiation of z with respect to x. Okay. And what about dx by dx? If I write dx by dx, it means differentiation of x with respect to x. So differentiation of any variable with respect to the same variable is always 1. It's not simply cancel out. Okay, it's a rule. Differentiation of x with respect to x is 1. Differentiation of y with respect to y is 1. Differentiation of z with respect to z is 1. So here in differentiation, this x, y and z are variables, but a, b and c, these are called constants. Okay, we use this a, b, c as constant. So the first rule is differentiation of variable with respect to the same variable is 1. The second rule is differentiation of any constant. Any constant means some number, okay, any number is always 0. For example, differentiation of d by dx of 2, differentiation of 2. So here it's simply a number, a constant is 0. We take this differentiation d by dx of c. Here if it is written that c is a constant, then differentiation of c with respect to x is 0. Even d by dx of any constant, differentiation of c or differentiation of 2 with respect to y. Here the differentiation is with respect to y, then 0. Means differentiation of any constant with respect to any variable is always 0. Okay, these are the things we have to keep it in our mind. And suppose the question is written as d by dx of, instead of 2, suppose they have written 2x. Okay, in this case what will happen? So here we'll take this constant outside the operator. Okay, so we will write 2 multiply by d by dx of x, and we know that d by dx of x with respect to x is 1, so it's 1. Okay, we will solve so many questions, and by the end of the chapter you will be able to solve, you will differentiate each and every function. Okay, all are simple, very simple question. The definition seems very tough or confusing, but the questions are very simple as well as very interesting. Now so many formulae. So the first we will see the algebra. Means suppose d by dx, suppose there are two functions and addition or subtraction, an operator is there between these functions. So d by dx of f of x plus g of x, these are the two functions with f of x and g of x, and there is a sign, plus sign. Then it's simply algebra, so we will find the differentiation of f of x plus d by dx of g of x. Okay, so algebra of function. So in this case we'll find differentiation of this plus differentiation of this, and suppose if it is a minus sign, then minus and minus, right? But this thing will not happen with multiplication and division. For multiplication we have product rule, and for division we have quotient rule. So if the two functions are in multiplication. F of x multiply by g of x. Okay. So in multiplication, we cannot write differentiation of first function multiply by differentiation of second function. It's wrong. So this rule is known as product rule. Very, very important rule. So let this be first function and let this gx be the second function. So according to product rule, let the first function be as it is, means f of x, let it be as it is, and we will differentiate the second function. Okay, there are two functions and it's multiplication sign between these two functions. So let the first function be as it is, so we can differentiate only one function at a time. So let the first function be as it is and then differentiate the second function, then plus sign. Now second time let the second function be as it is and d by dx of first function. This is called product rule. Okay, for multiplication. And what about division? So for division, d by dx of, suppose f of x divided by g of x. So this is called quotient rule or division rule also. So according to division rule, what we will do, in division rule, in quotient rule, let the denominator be as it is. Okay, instead of writing gx fx, I will write denominator and numerator. So in numerator as well as denominator, because here we will use minus sign, and in minus sign, since subtraction does not follow commutative law, so be careful. So suppose the function is numerator upon denominator, that then we will keep the denominator as it is, then d by dx of numerator minus, now numerator as it is, d by dx of denominator whole upon denominator square. Be careful, in product rule we can change this order. Okay, if you want you can take second function as it is, and if you want you can differentiate first function first and second function later. Okay, because it's a plus sign and addition follows commutative law. But here, because of this minus sign, we cannot change this formula will remain as it is. You have to keep the denominator as it is first, then always differentiate numerator first. Okay, in quotient rule we will first differentiate the numerator by keeping the denominator as it is, then minus sign. In the next we will differentiate the denominator by keeping the numerator as it is as well as denominator square. So if I rewrite, then we will get denominator f as it is means g of x as it is, differentiation of f of x, minus this time f of x is as it is, differentiation of g of x, and whatever the denominator, it's square.